Yeah, participants, is it audible? Hello, participants, is it audible? Hello?
Yes,
Hello,
sir.
is it audible? Yeah. Abhishek, are you there?
Yes, sir.
What about your result?
All clear, sir.
All clear, Aita? Congrats. 6 results have
Thanks,
been
sir.
announced, right? Yeah. So let me start as it is exactly 12 o'clock. In the last class, we were discussing regarding the different components of a process. And from examination point of view, you have 6 components of a process. And those have been shown on the slide. We have ID, unique identification number, that is being given by the operating system so as to know the status of each and every process. Second component is the code. Third one is the data. So what is a code basically? So code is a program or set of instructions what you write. Okay, that is the code of the process. So every process will be having some program. So again, what is a program? So program is set of instructions, right? So as to achieve a particular task. So that is the second component of the process. That is the code. Third one is the data. So this data is used in the execution of the program or the process, and the data is nothing but the input information that is inputted by the user, so via some keyboard or any input device as such. And the data can be also inputted via some database. And regarding the fourth component of process, so the stack, like I would also discuss one example. So where the stack is coming into picture in case where we use function calls and procedure calls. And fifth component is resources, and sixth component is the CPU state. So, like in today's class, let me discuss the next topic in your syllabus. That is a relationship between the process and the program. So we know the meaning of process. So what is a process and what is a program? So like in the starting slides of the second module, I have given a small table, so which can bifurcate what is a process, what is a program. So process is nothing but the program in execution. What is a program? Program is some set of instructions, sequence of instructions executed so as to achieve some particular functionality or a task or a job. So now let us see the relation between the processes and the programs. So the kind of relation what you can expect in between the process and the program is like 2 in numbers. So here the first type is one-to-one relationship, and second one will be many-to-one. So we have basically 2 kinds of relationship between the process and the program. So one is one-to-one relationship, second one is many-to-one relationship. Like as the name itself indicates regarding one-to-one relationship between the process and the program. So what it says, a single execution of a sequential program. So this means what? So for a single program, OS will be able to create only one process. So for one particular program, OS creates only one process which can handle the execution of that particular program. Okay. And regarding many to one, as again the name itself indicates, many to one relationship says that if you have one program, so then OS can create many number of process. So if I have only one single program, so let's say the program is very large or very huge program, right? A very big program is there. So for that, what OS will do is OS will create many number of processes so as to handle that huge, big, complex, large program. So when a so when a complex program is being divided into n number of subprograms, okay, like in this case, OS will generate multiple number of process so as to handle each subprogram. So that is the exact relation between this many to one. Okay, like same. So what I said right now is being expressed in terms of sentences where one-to-one relationship between the process and the program is for one particular program, OS will be able to create only one process. And in case of many to one, suppose if I have a very huge program, in that case, what OS will do is OS will be able to create many number of processes. Okay, so this OS will create n number of processes, or many processes will be created by the OS. Okay, so as to handle that huge program. So same information is being given here, like using a simple flowchart thing. Okay, like here we have it's a big program, huge program, complex program. Okay, so this particular complex program, if I want to execute using a single process, means that will take a lot of time. Okay, so as the single program is very big, huge, and complex program, so what I can do is, like I will divide this particular huge program into number of subprograms. Say 1, 2, 3, 4 are indicating the subprograms of the single huge bulk large complex program. So these subprograms created by the operating system, okay, are called as the primary process or the parent process. Okay, so what are these parent process or primary process? These are the subprograms which are nothing but the small divisions of a huge complex program. Okay, so again these subprograms will be divided into n number of sub-processes, where each sub-process, say there is P1 sub-process can handle the first subprogram, and second P2 sub-process can handle the second subprogram, and third sub-process called P3 can handle the third subprogram. So here what the OS will do is OS will create one sub-process so as to handle each and every subprogram 1, subprogram 2, subprogram 3, and so on. So these sub-processes which are created by the operating system so as to handle each subprogram are called as child processes. Okay, so now we have here two more concepts. So one is the parent process and second one is the child process. So what are these so-called the parent process and child process? So regarding the parent process, okay, so these parent processes are nothing but the subprograms, so which are being obtained by dividing the huge program, right, or a complex program. Okay, so we cannot expect this huge bulk large program. Okay, so just by creating a single process, okay, I cannot expect effective execution of this complex program. So for that, what we do is I'll be dividing this huge complex program, okay, where I'm able to have so many subprograms. So this subdivision of the main program, so as to obtain so many subprograms of the huge program, complex program, are called as the primary processes or the parent processes. Again, to handle each and every parent process, I can create so many child processes. So here P1, P2, P3, P4 are the child process, are the sub-processes, where each and every subprocess, say this P1 subprocess is created to handle the first subprogram, and here second subprocess called P2 handles second subprogram, and P3 subprocess is being created so as to handle the third subprogram, and so on. So here what OS does is OS will be able to create one subprocesses whose main function is to handle one subprogram. Hence, these are called as child processes. So same point like what I've discussed is been reduced to say three simple statements. Okay, so the first statement says that in a computer system, so multiple programs will be running, right? And it is very true. Why? Because in the memory, I need to maintain more and more number of programs so as to keep the CPU busy. Okay, and it's a very bad idea of generating only one process to handle one program. Okay, why? Because the amount of time consumed will be very much high. Hence, to reduce that, so what OS will do is OS will be able to generate multiple number of programs for a single program. Hence, a main program, huge program, it's a big and complex program, is being divided into so many subprograms. And to handle each and every subprogram, like I'll be creating the second stage is like I'll be creating the sub-processes, okay, or like nothing but the child process which can handle the individual subprograms. Okay, yeah. So again, the information regarding the parent process, also called as a primary process. So what are these basically? So the process created by the operating system for huge bulk complex program are called as the parent process or the primary process. So these primary processes are the processes so which are created by the operating system for huge, big, large, complex programs. And what about child process? So these child processes are also called as secondary processes. And like regarding the figure, like what we dealt in the last slide, so this P1, P2, P3, and P4 are nothing but the child processes. So these child processes will be able to inherit or make use of the resources that are being assigned to their parent process. So here, main point to be noticed is, so whatever the resources that are being allotted by the operating system, those resources will be allotted only for the parent process. Remember this. Okay. So whatever the process request for the OS. Okay. So for all the requests raised by a process for the resources to the operating system, the OS, what this OS will do is OS will allocate the resources only for the parent processes and not for the child process. And second point is these child processes will be inheriting or making use of the resources that are being assigned to the parent process. So this OS will not be issuing any sort of resources or assigning any sort of resources to the child process. OS will only assign the resources for the parent process, and these child process, say for example, so this child process P1 can make use of the resources that are being allotted to the P1, right? I mean, or this first subprogram, right? Or the first parent process. Similarly, the second so-called P2 subprocess or P2 child process make use of the resources that has been allotted to the second parent. Similarly, third child process P3 can assign, I mean, that can make use of the resources that are being assigned to the third subprogram. Okay, so by the OS. Okay, so the resources will be always assigned or allocated to the parent process and not to the child process. Okay, hence the child process can only make use of the resources that have been assigned to the respective parent process, and OS will not be allocating any sort of resources to the child process. Only the OS can allocate the resources to the parent process, and in turn the child can make use of the resources that have been allocated to the parent process. Fine. Yeah. So now seeing the benefits of child process. So what is the main use of dividing a huge program into so many subdivisions and creating one more again creating one subprogram and again creating one child process so as to handle the parent process. So what is the what are the main benefits of child process? Okay. So the first benefit is computational speed up. I can achieve a higher speed of computation. Second benefit is the priority for the critical functions. And third benefit is guarding a parent process against the errors. So now let me deal with each and every benefits individually. So what I can write down in the examination point of view for explaining the computational speed up as one of the benefits among the three benefits of the child process. So this regarding computational speed up. So what we are doing here is we are dividing a complex program into n number of subprocesses, like as I said in here, right? So this huge program will be divided into n number of subprograms. Okay, so the time taken by the process to execute will be obviously less, right? So if we doesn't, suppose if we do not create child process, so then OS must be able to do all the program execution in a sequential manner. So like when the child process are created, so then we can execute all the subprograms, right? Concurrently. So we can expect concurrent or independent execution of all the subprograms. Means I can expect the concurrent execution of say subprogram 1, subprogram 2, 3, 4, etc. So I can expect the independent execution of these subprograms, right, at the same time. So this will reduce the number of this will reduce the amount of time taken for running a process or application. Okay, so we can have the execution of all the subprograms like 1, 2, 3, 4, right, can happen concurrently, okay, just by dividing the main huge program into number of subprograms. Okay. And second advantage, what you can quote here is the priority for the critical functions, right? So this means that a child process that performs a critical function may be assigned a higher priority, okay, right? So this will help to meet the real-time requirements of an application. So what is the basic concept here is OS can assign different priorities for the critical function, okay? Like among the many subprograms available, right, we divide those subprogram with respect to the criticality and non-critical programs, right? And always the critical program, right, will be given highest priority, right, when compared to the non-critical programs. So for that, the OS can assign a different priority to these different child processes. Okay. And third advantage is guarding a parent process against errors. So this means that the kernel aborts a child process, right? If any resource, like suppose if an error is arising, okay, so while executing operation, the kernel will able to stop or abort a child process if any error arises during its operation. So the parent process will not be affected by the error, and it will be able to have a recovery action. That is, say the resources what child process is requesting. Suppose if that resource is not available with the operating system, so then the error will occur. Okay, so the error will rise, right? So like in such cases, the child process may guard the parent process. That is, the error will be handled by the child process itself, and the error will not be having any effect on the parent process. Okay, so we can write down the three benefits of the child process. Fine. So next concept is the child process in a real-time application. Like here we are showing how a child process will help to execute a particular application. Okay, so the example taken to explain how the child process will help us to execute a particular application. So the example taken is the data logger, right? Real-time data logger, like what we saw in the earlier slide that so this data logger will be able to collect the data samples like obtained from the satellite and storing them in a memory before the next data sample arrives from satellite. Okay, so the collection of data samples from the satellite and storing them in the memory before the next data sample arrives from satellite. So by taking this example, like we'll see how the particular application is handled by the operating system. So like as you can see in the figure, like we have here the parent process, and here the example for the parent process is the data logger, and its main function is to accept the samples obtained from the satellite. So this data logger is a parent process, and it will create three child process C1, C2, and C3. Okay, so this parent process, okay, so called the data logger, is able to create three child process, where the function of this first child process is to handle the handles copy samples from the special function register to memory, and a function of second child process is record the samples from the memory into the file, right? And a function of third child process is to housekeeping functions, means to like have some analysis to be done on the samples and storing the results and so on. Okay, so here this figure is indicating that so this parent process is nothing but the main function of the whole system, where the system is nothing but the data logger, whose main function is to accept the samples that is being sent from satellite. So like this will be acting as a parent process, and in turn this parent process will be again divided into so many child process, where C1, C2, C3 are the child function, child process, right? And a function of each and every child process C1, C2, C3, like has been mentioned right below here. Okay, yeah, so again same thing is being given here. So the primary process or the parent process is nothing but the data logger, and this will do like basically three functions, and all the three functions are being shown here, where the first function is you copy the samples from special function register into the memory, right? Like also called as buffer area. And second function of child process is to copy the sample from memory into the file. And third function of the child process is to do the analysis of samples, means recording the results into another file for more number of files. Okay, so here C1, C2, C3 are the three child processes for this particular single parent process, and same thing is being mentioned here. Okay, so we have a register here, and so from the register the sample is being copied into the memory, right? And that memory area like is called as buffer area, and from the buffer area we will record this into a file, right? And the results will be stored in another file. Okay, so here according to the criticality of these child process C1, C2, and C3, the priorities can be assigned by the operating system. So, but according to the the present example, right, what we have considered here, like we don't have any such so-called criticality involved here. So what we can expect here is, say first C1 can be executed, and after the child process C1 execution, second child process C2 can be executed, and after the second child process C2, the third child process C3 can be executed. Okay, so can have the example of this so-called the real-time data logger. So what we discussed in the module 1. Okay, same information. I mean, same example is being taken here to explain the concept of the primary process, right? Or like all the parent process and the child process, and how they will be handled by the operating system. And like in case of the daughter log application, so this can be taken as the parent process, where this parent process is able to create C1, C2, C3 as the child process, where the function of each and every child process is being given here, and also the flow is also being mentioned here. Okay, so next topic is the fundamental functions of kernel, so as to have the controlling of the process, and heading for this been given as implementing the processes. Okay, so like here we'll be dealing with the fundamental functions of the kernel, so as to have the controlling of the processes. So we have this particular diagram, like which is starting with the event. Like this event is nothing but the requesting for the resource. So this any request raised by the process for the resources can be acting as an event. So once the event occurs, means the first step. So what the kernel operating system will do is to save the context. The next step is event handling, and third step is scheduling, and fourth step is dispatching. Okay, so now like let me deal with each and every block individually. Okay, so we'll start with the basic concept of a process. So we know that a process is nothing but a unit of computational work. That is, this means that a process is an executable form of a program, and this program will do some useful task or work. Okay, so hence the operating system or the kernel's main task, main function is to control the operation of the process to provide effective utilization of the computer system. So this OS will be allocating the resources to the process once they start executing, right? And the OS will make sure that these resources are effectively utilized, right? So once the resources are allocated to one process, okay, those resources must not be shared by the another process, okay, until and unless the so-called process is a parent process. Why? Because the resources will be only allocated to the parent process, and no child process can be allocated to any resource. Okay, only the child process can make use of the resources that have been allocated to the parent process. Okay, so by having this much of information, let us deal with these individual blocks here. Okay, I repeat, heading for this particular figure is fundamental functions of the kernel for controlling the process, also called as implementing the process. So for this particular heading, here is the diagram according to the book, so which starts with the request for the resource, which will be acting as an event. Okay, so what is event? Basically, like the requesting for the resources is considered as an event, and once the event occurs, means so what all steps will be taken by the operating system in the job of controlling a process. So the first is the context save. So this context save means, suppose if I have like any two process, say that is P1 is having low priority and P2 is having high priority. So if this P1 of low priority process and P2 of high priority process is there, so then if P1 can be preempted when the higher priority P2 arrives. So this means that initially the CPU will be executing the like say P1 process, and if any high priority, say, so that is P2 priority is occurring, so then what OS will do is OS will be able to stop the execution of P1 process, and the content of the context of this P1 process or the information of the P1 process will be stored on the stack, and the CPU will be allocated to the second process P2. Why? Because the P2 process is of higher priority. Hence, the occurrence of high priority will cause the low priority process to suspend or to preempt, and I'll be saving the context or information related to P1 on the stack. Means you save the context of P1 right on the stack, and you execute the second high priority process. Okay, so what this means that like after the execution of this P2 process, again the OS has to take care of the execution of this P1 process. Okay, so to come back from high priority process to the low priority process, the OS will retrieve the information that was stored on the stack. Okay, so by retrieving the contents of the P1, the OS can start the execution of P1 process from where it had left to execute the second process P2. So this is nothing but the context save. Okay, and this will happen when the processes are preempted. Again, the word preempted means that forceful release of the resources from one process, and same resource will be given for the second process. And here the example taken is that here we have two processes where P1 and P2 are the two processes, and if the CPU is currently executing the first process, and upon the occurrence of any high priority process P2, what OS will do, what kernel will do is it will preempt the first process or the low priority process P1, and it will save the context or information related to the P1 process on the stack, and the CPU will be now given for the second high priority process P2. And after the execution of high priority P2 process, the OS will get back the information stored on the stack, and it will start executing again the low priority process P1. Okay, so for for this whole process, like this context save is very much important. And third one is event handling, like analyzing the conditions that led to the interrupt or the request by the process that led to a system call, and taking the appropriate actions is the job of this event handling. So the kernel will check or analyze the conditions say that caused or that led to the interrupt or system call, and also like the kernel will take some appropriate actions. So for example, this P2 has arrived. So once the occurrence of P2 is there, okay, so by raising the interrupt, the second process, a so-called high priority process P2 is able to raise an interrupt and indicate that it wants CPU. So the request of CPU is there, right? So by the second process, as P2 is of high priority, so the CPU is given to the second process P2 from the first process P1 of low priority. Okay, like here the main reason what led to the generation of interrupt is the occurrence of the second process. So this can be called as the event handling. Okay, and so next step is scheduling. So the scheduling is nothing but selecting the process that has to be executed next on the CPU. Okay, means so once CPU is released from a low priority P1 process, so then P2 has to be executed. Means P2, second process P2 has to be scheduled, right? Or the CPU must be given for the second process P2. Okay, so this switching from one process and again allocating the CPU for second process, like this can be called as the scheduling. Okay, So selecting the process to be executed next on the CPU is called a scheduling. Means once CPU is released from the low priority process P1, right? After the P1 execution, second process to be executed is this P2 process. Okay, so this like allocating CPU for second process like this can be called as the scheduling of the CPU time for the second process P2. And last block is dispatching, right? So the main function of this dispatching is to have the context switching, right? Again, the word context switching means that you preempt the first process and you can start the execution of another process. So the switching of CPU from one process to another process, that we call it as context switching. And for context switching, we need to go for the context save. Okay. So once we have the context save, okay, then we can go for the switching of the next process. So this dispatching nothing but OS will set up an environment to execute the process by loading its saved CPU state in the CPU to start its execution. So here the OS will create an environment so as to have the context switching to be done from the first process to second process, and that can be called as dispatching. So from examination point of view, so you can explain this like these statements, right? Along with this particular diagram, like having 1, 2, 3, 4, 4 number of steps, starting from context save to dispatching. So these are the steps or the functions of the kernel so as to have the controlling of the process or how these processes will be implemented. Like here is a diagram and here are the relevant information. Okay, so next we call, next topic is to go for the process state and the process transitions. Basically, like this process states, like we have seen in the last slides as well, where we had the process state as running state, blocked state, ready state, terminated state. So means any process can be staying in one of these states, like the running state or blocked state or ready state or the terminated state. So basically, like we have here 1, 2, 3, 4, 5, 6 number of states. Like we have various names for the process states, right? And these varies from book to book. Okay. So, but basically we saw that the process states were running state, blocked state, ready state, terminated state. And in the previous slides, these states of process were explained like, along with the relevant diagrams. Okay. So like now we'll see like in detail the information regarding each and every process state, starting from the running state, blocked state, ready state, and terminated state. Okay, so the heading is like the process states and the process transitions. Okay, so the state of a process is an indicator that describes the nature of the current activity of the process. So currently the process is in which state, okay, that will be indicated by the process state, and any process can be in like either running state or blocked state or ready state or terminated state, right? And that is, so whether the process is say busy or ready state or suspended or terminated or blocked or running, etc. Okay, so let us deal with the first state, that is running state. Okay, so this means that the CPU is currently executing the instructions in the process code. So like the CPU is busy in executing say P1 process, means that particular P1 process is currently having the CPU with it, means the CPU is currently executing the P1 process, right? Hence I can say that P1 process is now in the active state or in the running state. Okay, so this running state is also called as active state. Why? Because currently the CPU is executing the process P1, hence P1 is in the active state or in the running state. So next, coming to the blocked state. So this blocked state will be coming into picture whenever the process requests for a resource to the operating system, and if the resource is not available currently, so then the process must wait until the resource is free, right? So until that, the process is said to be in the blocked state. Or if the process is waiting for a specific event to occur, let's say, so then the state of process will be said to be as in the blocked state. So the process has to wait until a resource request made by it is being granted, okay, or if the process is waiting for an event to occur, right? So till the event occurs, the process will be kept in the blocked state. Okay. So next, coming to the ready state. So the process wishes to use the CPU so as to have the continuation of its execution. So, but it is not been dispatched. So this means that so the process has requested for some resource. So, but if another process of high priority comes, okay, so then the process will be put in the ready state. Okay, right. So means the high priority process like will be always executed first when compared to the low priority process, right? And last state is the terminated state, right? So once the execution of a process is over, so then the process execution has completed normally, right? If then, or because of some say like error is occurring while executing the process, so the process will be aborted, okay, aborted by the OS. So then the process will be entering into the terminated state. So here, like basically we have here say about 4 reasons are there. So based upon which any process can be going into the terminated state. So that will be seen here. Okay. Here the first condition is self-termination. Second condition is termination by a let's say termination of a process by a parent. And third reason for termination of process is exceeding the resource utilization. And fourth reason is abnormal conditions during operation. So like these underlined are basically the 4 reasons based upon which any process can be terminated. And before seeing this, let me have this last state called as terminated state. So where if so once execution of a process is over, or if the process is encountering an error while its execution, so then the process can be stopped by the operating system. And if that happens, means any process will be able to enter into the terminated state. And next is the causes of fundamental state transition for a process. So under what all conditions any process, say P1 process, can be switched to another states. Okay, so based upon what all reasons you can expect any process to be having the state changes or state transitions, that will be seeing next. Like as we have only 2 minutes remaining, let me wind up the class here itself, so you can join for the next class where we're discussing the causes of the fundamental state transitions of so for a process. Okay, so like regarding the assignment one like has been given for you. Okay, so you can attend like those questions, like around 12 questions were there in assignment 1. So you can write down the assignment like as an assignment book, or you can take some sheets and you can have the writing of assignment and keep them ready. Okay, so for this class, let me wind up here. Fine. Thank you.